Hello, my name is Elijah Potter, and I'm a data scientist currently working with SMU on a recent ask that your team at Coughlin Automotive brought to our attention. Our goal here is to construct a time series model to help predict private car orders based on a set of website metrics that you provided. We've analyzed this data set and constructed several time series models that I'd like to present to you so that we can work together to identify the best way forward. First, here's a subset of the data provided to us. Included here are date, sessions, which are counts of site visits, test drive requests, which are the number of requests per day, total configurables finished, which are the number of vehicles created through your online tool, online leads, which are the number of times customers requested contact by Coughlin Automotive, offer requests, which are the number of times per day a customer requested pricing on a given vehicle, keep me updated events, which are the number of times a user clicked notify me on your webpage, dealer locator usage, which is the count of the number of times that a user clicked on your GPS locator tool. And lastly, private orders, which is the count of orders per day, which is what we're trying to predict. Our first step here was to identify which variables may be redundant. We can see here that there exists a fairly strong correlation between sessions and configs finished, sessions and dealer locator, lead counts and drive requests, and configs finished and dealer locator. Next, we analyze the orders time series. The realization here shows plenty of signs of wandering, and the spectral density plot shows a likely weekly trend with a harmonic at about 0.29. Using these findings, we created our initial model of an ARMA 6.4, which predicts daily sales based on the last 6 days of sales data, as well as the last 4 days of white noise. This model has an AIC of 7.26 and a white noise variability component of 1,366.11. Taking a look at our model predictions, we see here a 10-day prediction and a 55-day prediction, which begins to regress to the mean as predicted. And here we can see our model performance metrics, which will be useful when we fill out this table with the other models to come. Next, we modeled the sales data using an ARIMA 605 stationary component as well as a weekly seasonal component. This model has an AIC of 7.46 and a white noise variability of 1,659.04. Next, we can see here our 10-day prediction and our 55-day prediction, which really illustrates the repetition of that weekly cycle. Now, when we compare our two models, we can see that the ARMA 6.4 wins out in every category. Our next model is a VAR model, which predicts daily sales based on the previous 3 days of selector predictor variables. These include sessions, offer requests, configs finished, test drive requests, and private orders. Here we can see the 10-day prediction of this model and the 55-day prediction. It is interesting to note that this model seems to quickly regress to the mean of private orders. Now, when we compare our models, VAR wins out on the 10-day ASC, but our first ARMA 6.4 model excels in the other categories. Note, however, that when we include a simple average model, which just predicts the overall private order mean for every day, it actually beats out the VAR model. Next, we constructed a neural network to predict daily sales. Note here that when we take the original realization and then predict the private sales for those days using our neural network, we get very similar behavior. Now here we have the 10-day forecast, followed by our 55-day long-term forecast. Here we see that our simple average model still wins out on the short-term ASE, and the ARMA 6.4 model has better scores in other categories. Our next step was to construct an ensemble model from 2 of these candidates. Our clear initial choice was the ARMA 6.4 model. Our next choice was the neural network model. Despite behaving poorly in terms of ASE compared to the other models, the neural network modeled our initial realization nicely, which indicates that it fits the data quite well. This ensemble model took the mean predictors of the ARMA 6.4 and the neural network models in order to predict daily orders. Here we see our short-term forecasts and our long-term 55-day forecasts. Finally, we can compare all of our models and see that of the time series models, the ensemble wins in terms of short-term ASC and the ARMA 6.4 wins in terms of long-term ASC. Given that our goal is to supply actionable predictions, we recommend the use of the ensemble model moving forward. I'd like to note, however, that the simple average model performed quite well in comparison to the time series models. This may indicate that a further investigation is required to suss out more potential predictor variables to create the ideal model. Now, I just want to thank you for your time, and if you have any questions, please feel free to reach out to me via email. Thank you.